Good afternoon all. Am I audible?
Yes, ma'am.
Okay. Thank you. So in the last lecture, we have seen 802.5, IEEE 802.5. So there is only one standard remaining regarding with the IEEE. That is nothing but IEEE 802.6. So totally we have seen IEEE 802.2, 3, 4, sorry, 802.345, and this is 802.6. Okay. So IEEE 802.6, this is mainly used, or it is also called as a distributed queue dwell bus. Okay, remember the long form because it is asked for the MCQ. So it is also called as a DQDB. It is distributed queue dwell bus, or sometimes the option may be double bus, but the correct long form is distributed queue dwell bus. Okay, so IEEE 802.6, IEEE 802.6, it is called as an DQDB. So it is a man protocol, that is, it is mostly used for the metropolitan area network, that is to cover the large area. It is mainly designed. It can be defined as a high-speed shared medium access control, that is MAC protocol, that is used over the bus network. Okay, means for the working of the 802.6, the bus network is used, and it is as it covers the large geographical area. For that's why it is also called as a high-speed shared medium access control protocol, that is MAC protocol. So how it works or how it look, I'll show you the diagram. From that you will get understood. So it has two unidirectional buses, means to work for the working or to send and receive the data. It has two unidirectional buses. Unidirectional buses in the sense, it is having two wires. Okay, two-way communication we can see for controlling purpose. For controlling purpose means what? As it is mostly used for the man, that is large area, so it may be possible that there are lots of frames are available for transmission purpose, right? So to control all these frames, or to have a control communication within all the stations, these two buses are used. Okay, where the bus can carry the data like video and voice over a network with a bandwidth being controlled as per the time slots. Means mostly, or this DQDB is it is carrying all type of the data as like video, audio, and all type. The advantage of using the paired bus is that it is used to tackle failure configuration. Okay, means if something, if any one network or any one transmission get failed, then the alternate transmission can be carried out. That's why these two or paired buses are used in case of the DQDB. It can be extended, means we can extend the network size up to 30 miles at 34 to 55. That is, we have to just add the number of nodes in a network. So this is a simple diagram with the help of which you can get understood actually how the nodes or how the stations are connected with the help of the DQDB. So you can see here 1, 2, 3, 4, and 5. Five stations are there. There are two buses, bus A and bus B. Buses in the sense, it is the way of communication, means these are connected like this. Okay, now as it is two-way communication, means two buses are there, they are marked by using separate symbols. You can see here. So where square is used, we can say that it is the start of the bus A, right? So you can see at the station number 1, here square is marked, so it is nothing but the start of the bus A, and it goes to 2, 3, 4, 5, and here it ends, so that's why it is marked by a triangle. So it is the end of the bus A network. Okay, then similarly for the bus B. So bus B, so as for session number 5 is a starting point for the bus A, and it is marked by the square, and station number 1 is an ending point for the bus B, and it is marked with a triangle. ठीक है. So in this way these two buses are being represented or being used. Now how the data is transmitted, I'll show you with example. Okay, now just tell me whether you understood this. what is mean by the dual bus. दोन बस किंवा डबल बस असण्याचे मीनिंग काय आहे की दोन बसेस और दोन वे न कम्युनिकेशन होतं. ठीक आहे, आयदर दिस वे और दिस वे और राईट टू लेफ्ट और लेफ्ट टू राईट. राईट. सो ज्यावेळेस डेटा जाणार आहे त्यावेळेस कसा जाईल, फ्रॉम सपोज इट इज इन द बस ए, देन it will travel from right to left. If it is in B, it will travel to left to right. Now which data will be in bus A and which will be in bus B, that design criteria is there. I will tell you. Just remember that in this way this communication is happening. Right. Now next, how the working is done. So as I told you, the head of the bus A, that is station 1, generates an empty slot for use of the bus A. Right. Now suppose data is being transmitted from this one station to the any other station. So what it does, it generates an empty slot for use of the bus A. Or we can say that whenever data is to be traveled from bus A, the starting station always generates an empty slot. So if suppose data is traveling from the bus A, so station A or station number 1 will generate an empty slot. If it is traveling from the bus B, then station number 5 will be generating the empty slot. For what purpose? For transmission of the data. Right. So as station number 5 is a starting point for the bus B, so it will generate a empty slot for the transmission of the frame. Similarly, the head of the bus B, that is station number 5, as I told you, it generates an empty slot for the use of the bus B. ओके, सो जर सपोज बी बस मधून जाणार असेल तर कोण जनरेट करेल, स्टेशन नंबर 5 हा जनरेट करेल एम्प्टी स्लॉट. एम्प्टी स्लॉट म्हणजे काय असणार आहे, तर त्याच्यातून तुमचा डेटा ट्रान्समिट होत राहील. सो जर ए मधून जाणार असेल, स्टार्टिंग स्टेशन इज स्टेशन नंबर 1, सो इट विल जनरेट अ एम्प्टी स्लॉट. If it is from the B bus, then starting station is 5, so it will generate a empty slot. ठीक है. The empty slot travels down its bus until the transmission station drops the data into it and intended destination reads the data. हा empty slot कुठे travel होत असतो, so for what bus it is generated, it travels to through that bus. Okay, so if station number 1 generates the empty slot, it travels through bus A up till now, up till what, so it will travels unless and until it reaches to its destination. Exact intended means exact destination, and that destination reads the data. Okay, similarly for the bus B also. Here is an one example that I have shown over here. So please see this example. So same 5 stations are there, 1 to 5, and yes, 1 to 5 stations are there, and the data is traveling from these stations, right? Now suppose, am I audible now? Are you listening?
Yes, ma'am.
Yes.
Yes,
Okay.
ma'am.
Okay. Thank you. So suppose this is an example, right? And there are 5 stations, and from these 5 stations, for example, 1 second, someone is joining. Okay. Okay, suppose if station number 2 wants to send the data to the station number 4. Okay, if station number 2 wants to send the data to the station number 4. So what it will do, it will chooses a slot on bus A, station 4 is downstream in the bus A, or let it be. So suppose station number 2 wants to send the data to station number 4. So as you can see, station number 1 has created an empty slot, right? This is again, you can see here. So station number 1 has created an empty slot here, this one, and this empty slot is traveling through bus B, sorry, bus A, right? Now station 2 wants to send a data to station number 4, so station 1 will generate an empty slot and this will travel through this. So when station number 2 sends the data, so it drops its data to this empty slot. So you can see here it is filled now. So it will go through the next station, through the next station, and so on. So unless and until it reaches to its destination, this this slot is traveled through this bus, right? So whenever this any station gets an data, it first checks the address. This address is also called as a MAC address. Okay, MAC address. So सपोज ह्या स्टेशनला स्टेशन नंबर 2 ला काय करायचंय, 4 ला डेटा सेंड करायचंय, पण पहिल्यांदा डेटा कुठे येणार, इट विल गो टू द स्टेशन नंबर 3, right? So this station or this data is having this MAC address, so this station reads the address and just filters that data to the next station, because that data is not for station number 3, because data is having the address of station number 4 only. Okay, in this way it reaches exactly to its destination. समजलं working how the data is being transmitted? Yes. So this example is just to show you how the station is generating the empty slot and how it is traveling. Okay, so it is a bus structure. So it is one bus, it is an second bus. Okay, now this is one more example which is shown in a book. This example I have just given to simplify this, because from this diagram it is quite difficult to understand what is happening exactly. Okay, so that's why I have shown this example. Now here we will get understood the difference or the working of this DQDP. Now see here, so as I told you, there are two buses, A and B, bus A bus and B bus. So it is a dual bus. So every bus is having its starting point and ending point. So that is shown over here. Start, head, end. Here it is head, end, and it is ending. So this is the dual bus structure, right? So you can see here A, B, C, D, E. These are the 5 stations, right? So these are the 5 stations and this is the developers. Now I'll tell you what this exactly diagram tells you. If the question is asked in the exam, you have to explain this with this example, not with this diagram, because mainly the working, this diagram I have used just to simplify the concept. Okay, so this diagram is important for the DQDP. Now what is this diagram tells, just I'll explain. So it is these 5 A, B, C, D, E. These are the 5 stations, and this is a 12 bus structure, A and B. Now every uh, bus starts at some point and every and or it ends at a some point. Right? Okay. Now two parallel or unidirectional buses are traveling, or they are carrying the data unidirectional, parallel or unidirectional you can say, because in the bus A it will travel through this only, and in bus B it will travel to this direction. That's why it is called as an unidirectional bus. Okay, it carries the data within it, with the stations attached to both the buses in the parallel. So all the stations are attached to these buses. Now each bus has a head end, and its head end means starting end and ending node. So every bus is having starting point and the ending point. Each cell travels from the downstream from the end. Okay, start to end. Now every bus, or sorry, every station is having two, every station is having some data to carry in it in it, and it every cell carries 44 bytes payload or 44 bytes maximum data within it. आता प्रत्येक स्टेशन किती मॅक्झिमम डेटा ट्रान्समिट करू शकतो तर 44 बाईटचा डेटा ट्रान्समिट होतो. To transmit the data, a station has to know whether the destination is at its left side or it is at right side, right? Suppose station D wants to send a data, so station D should know who the destination is at its right side or it is at the left side. The reason is that if the destination is at the right, the sender should use the bus A. If the destination is at station's right side, then it should passes through bus A, otherwise it should use bus B. That is decided, and that is the reason I told you that how the data is traveled through this, it is decided by using this criteria, right? ज्या स्टेशनला डेटा सेंड करायचा आहे त्याला काय माहित पाहिजे, माझं जे डेस्टिनेशन आहे किंवा माझा डेटा जिथे जाणार आहे तो राईट साईडला आहे का लेफ्ट साईडला. इफ इट इज ऍट द राईट साईड इट शुड युजेस बस ए. जर तो राईट साईडला असेल तर तो काय करणार आहे, बस ए मधून जाईल. and if it is at the left side it should use bus B. why? Because it is an unidirectional, असं जाणार आहे डेटा बस बी मध्ये आणि ए मध्ये असं जाणार आहे. सो जर डेस्टिनेशन ई असेल तर स्टेशन डी शुड यूज बस ए, and if the destination is A, then it should use bus B. Correct? The station queue up in order, they become ready to send and transmit in a FIFO order. So what it does, all this data, or all the these frames, these are queued in a bus like this, and these are transmitted by using FIFO, that is first in first out. जी फ्रेम पहिल्यांदा येईल ती पहिल्यांदा ट्रान्समिट केली जाते. इन दॅट ऑर्डर द फ्रेम्स आर बीइंग ट्रान्समिटेड. समजलं इथपर्यंत हाऊ द बसेस आर chosen for transmission of the data? Yes, have you understood how this is chosen? So the station, those who want to send the data, it should first check destination side. If it is at the right side, it should use A bus. If it is at the left side, it should use B bus. And all the frames are arranged in a queue and they are transmitted by using the first in, first out structure. Correct. Now you can see here every station is having two counters. These are the counters. Okay, RC and CD. Every station, RC and CD. So each station it maintains two types of the counters that are nothing but the RC and CD. So the RC, this counter, it counts the number of requests pending until the station itself has frame to send. Okay, so what it does, it just keeps the track how many requests are there that are traveling through the bus. Okay, and CD is used, or there is no long forms for the CD. It is just it is used when the request counter is incremented by 1, and that time it is getting updated. So I'll tell you. So RC is nothing but the request counter, and CD it is used when request counter is incremented by 1. Now initially you can see in the first diagram, initially both the counters are set to 0, RC and CD. Both counters are set to 0, both the counters initially. Now whenever any station having the data to send, at that time these counters are incremented step by step. How? I'll tell you. Now suppose station D wants to send a data or it makes a request to send a data. At that time, station C, B, and A both are incrementing their counters. Okay, you can see here. Here, packet is given. Now station D wants to send a data. So what it will do, it will send an request that I'm sending the data. So whenever station sends an request, this station number C, B, and A, they have incremented their counters. You can see here RC is equals to 1 now. So what it does, it is nothing but some station is sending the data. Correct. So only this station number station E, it has not incremented. You can see it is now 0 only. RC is equals to 0. So स्टेशन डी न काय केला की डेटा मला सेंड करायचे, सो त्याने रिक्वेस्ट सेंड केली. बस बी मध्ये तो ट्रॅव्हल होतोय. सो त्याच्याकडचे सगळे जे स्टेशन्स आहेत त्यांनी काय केला, स्वतःचा आरसी काउंटर इन्क्रीमेंट केला एक्सेप्ट दिस स्टेशन. Correct. Now suppose packet has reached or it is traveling through the bus B. Now suppose again station B again suppose want to send a data. So you can see station B has put a request for the data sent. Right. At that time what will happen? So you can see station A has incremented the RC counter by again 1, because this earlier one of this station D and one more for the station B. Whenever station B want to send a request at that time, want to send a data at that time, it just makes the RC counter as a 0, or it resets the 0 because already it has a 1. So it resets the counter as a 0, and that one is transmitted to the CD. That's why I told you that CD counter is activated or it is incremented when this RC counter is incremented by 1. So RC काउंटर पहिल्यांदा 1 होता, त्याच्याकडे ऑलरेडी एक रिक्वेस्ट कॅरी आउट होत होती, पण त्याला स्वतःचा पण ज्यावेळेस फ्रेम सेंड करायचा आहे त्यावेळेस तो काय करतो, स्वतःचा काउंटर 0 रिसेट करतो आणि CD 1 करतो. त्याचं मीनिंग काय झालं, ऑलरेडी D has been sent by using B station, and it has station number B is sending this second frame. समजलंय? Example, yes or no? Similarly here it is given that suppose station D is again sending the data, so it will send a request and all. So same, only 3 diagrams you just remember, remaining is same. It just increment and decrement the counters. समजलेत हे 3 पार्ट्स काय आहेत डायग्रामचे, or should I repeat again? Yes, समजले? Any doubt? Any doubt? Are you getting? Yes, rule number 1.
Ma'am, C diagram is repeated.
Which one? C1. Okay. Any other in rule number 3? I
Yes,
understood.
ma'am. Diagram repeat करो ना.
Okay. अजून अभय. अभय. Roll number 38. 38. Right. Okay. So I'll repeat the diagram once again. So this is an 802.6, that is IEEE 802.6 standard, which is used or it is also called as the DQDB, that is nothing but the 12 Q distributed queue dwell bus. So it is mostly used for the man, that is metropolitan area network. Metropolitan is large city, it, for example, large city it covers to travel the data. That's why the arrangement is done in a two-way type of the communication. That's why it is called as an 12 bus. Okay, so this is an example just to show how it is working. So as you can see, A bus is there, B bus is there, two buses are used. Now each bus is having starting point and the ending point, which decides in which way the data should travel. So for the bus B, it should travel in this way, and for the bus A, it should travel in this way. Right. Now, station A, B, C, D, E. Five stations are there. They are connected in this bus, in these two buses. Each station is having two counters. That is nothing but the first one is the RC and second one is the CD. These are the two counters. RC stands for request counter. It stands for request counter, and it is either 0, means both the counters are 0 and 1. Okay, it is incremented by each and every action. So you can see here. Now suppose first, now before going for any request, for initially all the counters or both the counters are set to 0, rccd 0 0 0. So in figure A, both the counters are 0. Right. Now any station or the station, those who want to send or those who is sending the data to the destination, that station should know in which direction the destination is available, whether it is at the left side or it is at the right side, to decide the transmission or to decide which bus should be chosen. Okay, because this A bus travels in this direction, only one way direction, and this bus travels in only this direction. So it should not be the case that suppose station D wants to send a data to station A, then it should travel to the bus B only. Okay, so that's why it should know the destination should be at the right side, or it should be at the, or it is at the right left side. ठीक आहे. So initially both the counters are set to 0. दोन्ही पण counters 0 ला set केलेले असतात. Now suppose station D want to send a data. Station D ला काय करायचंय, transmit करायचंय. So it put a request for the transmission of the frame. So it is having the packet and it has put the request for the transmission of the data. Suppose destination is, for example, somewhere here. A is the destination. Okay, so whenever station D puts a request for the transmission, the station C, then B and A, they increment their counter by 1. So you can see here, RC is equals to 1, RC is equals to 1, and RC is equals to 1. Station E has not incremented because there is no use of this station now, because data is traveling through this way only by using bus B only, and this is station E, so it will not travel to this. So RC and CD both are 0 for the station E. Correct. So RC is incremented by 1. So this data will travel through this and it will reach to the destination. Unless and until it reaches to the destination, this counter are set. ठीक आहे. जोपर्यंत हा डेटा जो स्टेशन नंबर डी न सेंड केलेला आहे तो त्याच्या डेस्टिनेशनला पोहोचत नाही, तोपर्यंत हा काउंटर सेमच राहतो. ठीक आहे. नाव सपोज स्टेशन बी ऑल्सो वॉन्ट टू सेंड अ डेटा. ठीक आहे. स्टेशन बी, अजून स्टेशन डी चा डेटा रीच झालेला नाही. In between, suppose station B is having the packet or the frame to send. So what it will do, it will put an request. So whenever this station B puts an request, at that time, at that time, what it will do, this station A increments it by 1. So you can see in RC is equals to 1. Now RC is equals to 2. But as RC is 1 for the station B initially for station D, so what it will do, it will just put this counter in CD and reset its own counter to 0, because B is a host now. It is just sending the data. त्याच्यामुळे त्याचा काय आहे की काउंटर RC चा 0 आहे, because it has already sent a request. RC is used for the request counter. ठीक आहे. इथं पण बघा, स्टेशन डी सेंड करतोय, फ्रेम सेंड करतोय, पण त्याने स्वतःचा काउंटर 1 2 केलंय का? नाही केलेला. इट इज जस्ट 0 ओनली. So similarly, station B want to send the data. So what it will do? It will make a count, reset a counter, a request counter to 0 and increment, or it just transfers this counter to the CD. ठीक आहे. नाउ सपोज एन एक्झाम्पल घ्या की आता सपोज सी ला पण सेंड करायचा डेटा, त्यावेळेस काय करेल सी? इट विल मेक इट ॲज अ 0 and CD will become 1. Right? In that case, in case of the C, again RC will become 1 and CD will become 1. Am I correct? Because RC काय आता 0 आहे ना P च्या वेळेस, आणि जर सपोज नेक्स्ट मी C ला घेतला डेटा, तो इकडे रिक्वेस्ट पुट करेल. In that case, for C, RC will be 0, CD will be 1, B, RC will be 1, CD will be 1, A, RC will be 3, CD will be 0. Am I correct? समजलं आता? Any doubt? Yes, any doubt? समजलं? Either say yes or no. Or should I know?
Yes, ma'am.
Yes.
Okay, understood. Good. So DQDB, so if you go through the question papers, so mostly DQDB is asked. So please remember, it is very simple. You have to just remember this diagram only and what is the purpose of the DQDB. That only you have to remember. So this is just an explanation, whatever I have explained now for this DQDB. So समजलं इथपर्यंत IEEE 802.6. So up till now we have seen the standard for 802.3, then 802.4. 802.3 is Ethernet, 802.4 is a token bus network, 802.5 is a token ring network, and 802.6 it is an DQDB. So total 4 IEEE standards we have seen. Out of these 4 we have to implement, means for the practical we have to implement 3, that is IEEE 80.3, 4 and 5. Already we have seen the programs for that 08.34. Only one is remaining, that is IEEE 802.5. It is again very simple. We have to just take an input from the user for the frame format that is shown as like this. So we have to just take an input for the SD, AC, FC, and we have to just display the data whatever we are taking from the user. So I'll give you, or I'll post this program on group. You just go through it. Tomorrow if you have any doubt you can ask me in that program, because it is same as like a 3 and 4, 802.3 and 4 that we have already implemented. Only one field is changed, that is AC field. Therefore that we have to just take an input. That only thing I have added in the earlier program only. So you can also add, or you can just modify that program. I'll share that program in a group so that you will get understood. Okay, so one more point we will see within, because already lecture is late started. I have started it late. So can we move for 5-10 minutes? Yes, can we extend? Yes. So I got a message from Vishal. Okay, thank you. So the next point is the bridges. Okay. So bridges, these are used to connect the lands. Means multiple lands are connected, multiple two, three, four. These lands are connected with the help of the bridges. So bridges are used to connect multiple lands. Bridges operate in a data link layer of the OSI model. Data link layer, that is second layer of the OSI model. So this operates in a data link layer of the OSI model. So a network bridge or the bridge, it is a device that divides the network into the segments. How it divides, how it looks, I'll show you. So it is a device which divides the networks means into some segments, or we can say into some parts, and these are connected by using the bridges. Each segment represent a separate collision domain. Okay, means each segment is having separate set of nodes or set of stations that it handles. Means suppose this is one type of the segment and it contains total four stations. It contains, suppose this is second domain, so it contains suppose three. So this segment handles only these four, this handle only these three. Okay, so each segment represent a separate collision domain. So the number of collisions on the networks are reduced. So obviously, instead of having seven station in one network, it is getting divided, or the load is distributed. Each collision domain has its own separate bandwidth. Means this is having its own bandwidth, it is having its own bandwidth. So a bridge also improves the network performance. So as the load is divided, it just improves the performance. It inspects the incoming traffic and decide whether to forward it or the filter it. What is the meaning of it? I will tell you in the next diagram. It is available. So depending upon the address of the destination, it decides, or the bridge decides whether that particular frame or the incoming data should move forward or it should get discarded. That is being decided. Each incoming Ethernet frame or each incoming frame is inspected for the destination MAC address. So as I already told, so it just checks the destination address and then decide whether to forward or discard. If the bridge determines that the destination host is on another segment of the network, it forwards the frame to that segment. Means what? Suppose station is available in this segment and it is sending the data to this segment. So what it will do, that data will first go to this bridge and then it will forward it to this particular segment. Right? Similarly for the reverse also. So there is one diagram for which you will get understood. Yeah, this one, this diagram. So this is a bridge, okay, which is used to connect. This is one segment. You can see here collision domain one. This is one segment, and this is a second domain. Okay, so there are two hosts are available, or two stations are available in this, and here two stations are available in the second domain. Okay, so what is this example I have just given here? In this picture, we have a network of four computers, A, B, C, and D. The network is divided into segments by a bridge, or we can say these are connected by using the bridge. These two networks are connected by using the bridge. Each segment is a separate collision domain with its own bandwidth. Each segment is a separate collision domain. This ह्याचा जो हे असणार आहे बँडविड्थ असणार आहे ती सेपरेट असणार आहे याची बँडविड्थ सेपरेट असेल. Let's say for example host A want to communicate with host C. Host A want to communicate with the host C. So what it will do, host A will send the frame with the host C's destination MAC address to the bridge. Host A काय करणार आहे, फ्रेम कोणाला सेंड करेल, ब्रिजला सेंड करेल. कोणाच्या ऍड्रेसची, सीच्या ऍड्रेसची, विथ होस्ट डेस्टिनेशन मॅक ऍड्रेस टू द ब्रिज. and the bridge will inspect the frame and forward it to the segment of the network host C in which is available in the segment. So ब्रिज काय करेल ऍड्रेस चेक करेल आणि ज्या सेगमेंट वरती सी अवेलेबल आहे त्या सेगमेंटला तो ती फ्रेम पुढे ट्रान्समिट करेल. ठीक आहे. So in this way bridges are used to connect, you can say, the multiple LANs with each other, and every LAN or every collision area is having its own bandwidth which is maintained over there only. Okay, so we'll stop here because there are lots of things are there, so continuously we'll see in tomorrow's lecture. Okay, we'll stop here. So these are the tomorrow we will finish our 5th chapter. Any doubt? Anybody is having any doubt? No. Okay, fine. Thank you. So I'll take a presenting.